Hello everyone, my name is Vimal Raj. I'm a lecturer from the mechanical department from GEMS Polytechnic College. So today we're going to discuss about the part 2, that is types of engineering material part 2 from the unit mechanical engineering material. So this is a unit 1 according to the SPT syllabus. So let's get into the video. The content that we're going to discuss today is types of engineering materials. So that is a part 1, this is a part 2. First one is composite. So last class we would have discussed about the metal and alloys, polymers, composites, right? So we have deeply discussed on composites. Composites is nothing but it's a material also called composition material or shortened to composites or material made from two or more constituent materials with significantly different physical or chemical properties that when combined produce a material with characteristics different from the individual components. So basically this is a composite material wherein which combination of two different materials completely different in physical as well as chemical properties. So combination of two different materials forming a single material. So basically when mixing with two chemicals you get a different chemical. We used to do it in the chemistry lab, right? So combination of two different chemicals, we put it in the test tube, and when we shake in it, when we do the stirring work, it gives you different material, different chemical, right? So same thing, the composite of two different material, it could be iron content could be there, wherein which another material could not have an iron content. So combination of two different, totally the physical characteristics and the chemical characteristics will be completely different. So when these two combines, it produce or it gives a new material. So that is called the composite material. So this is a example for the composite material. Example would be clearly example. So this is a material used in Boeing 787. So we all know the flights. So nowadays during this pandemic situation, we have the only way of transport is the air transport, that is the going in the flight. So many of you would have traveled in the Boeing flights, and many of you would have not traveled in Boeing flights. So see, when you take this flight, so this flight is a combination of different materials. So when you take a flight, so when the Wright brothers they found out the flight, they initially tested with different materials, but everything got failed. And finally, when the technology developed, technology advancement happened. So in order to travel in the atmosphere above the 30,000 feet, so when they travel in the 30,000 feet, the atmospheric level will be totally different, and it has to carry the whole body of the flight. When there is only two turbine engines will be there, so it has to carry all those things in the same weight. So if they used the iron material, what would have been happened? The flight could now taken off. It could not travel above 30,000 feet, and the weight would be more. Because of the weight is more, it cannot travel. So because of that, it could end up in an accident. So as we all know that recently there is an accident that happened in Calicut. So that is we feel very sorry for that. And so this is a thing happens. So when you see this components, I will just show you here. See, there is a 50% is composite material they use. Composite material is combination of two different materials. So the blue area that is being all over the flight is a composite material. That means that is the reason whenever you travel in the flight, they will be doing a thorough security check. Even a small screwdriver, if you have it in your bag, they will tell you to put it on the dustbin and go, because that small screwdriver can damage the flight, because the material that has been used in the flight is very light material. See, it is durable when traveling in the air, but it is not durable when it falls down. That is the reason. See, when you use a iron material, the ductile, the durability will be more, but when you use a composite material, depends on the material combination, because they use different material for different purpose. For when they use it for a flight, the purpose is totally different, because they need to carry the weight of the whole flight, and they have to carry the passengers, and we have to travel in about 800 kilometers per hour, like that. So they use a different material. So that is the reason during the security check and all, they will be very keen that they will be checking everything, that you should not carry a gun or fire thing anything, because that even could damage the flight's body. That's the reason it's very they do a security check. So that's the reason it is more than 50. I mean, it's almost like all the 50% of the flight is being made with a composite material. The blue area indicates a composite material. So that is the reason even a small crack happens in the body could end up in a blowing on the flight, blowing up of the flight. So see, this is the blue area is a carbon, I mean composite, when it's a carbon laminated area. So it's not a hard material that is used. It's a light material, because the flight should be light in weight in order to travel the whole body weight, because only two turbine engines are there. It can only travel. It can only lift up to a certain weight, right? So only two turbine engines are there. So with the two turbine, they have to travel. The whole flight should be traveled. Should be carried out. So the next one is carbon sandwich. So this blue area is a carbon sandwich area. So the green area is a fiber glass area. So the next one, the red area is the aluminum area, and the yellow area is the aluminum steel or titanium pylons. So basically all the material that is being used in the flight is a lightweight material, because of the traveling in the air, because it has to travel in the atmosphere about 30,000 feet, right? So this is the example. So combination of two different material forming a new material, that is the composite. Okay, so I think this example could be a good example, because I love this example. Next one is composites are further classified as composites, laminar, particle reinforced, and fiber reinforced. So these are the further classifications. Ceramics are further classified as ceramics is defined as any inorganic substance to do not contain carbon or its compound non-metallic material. So basically, wherein which it should not contain any carbon material, carbon or its compound, that is a ceramic. So ceramic is further classified into metal oxides, nitrides, carbides. So metal oxides are further classified into alumina, beryllia, zirconia, glass, and glass ceramic. So these are the ceramic types of the different types of ceramics. So they use the ceramics for a different purposes. So basically, the zirconia, if you take zirconia, they use the zirconia as an example. They use it for the teeth, for making of the teeth. See, people who have a broken teeth, when they go to the dentist, they will say that okay, you have to do a root canal, and we will put a cap on that. That cap they put is a zirconia cap. It will be looking exactly like the teeth, and it has a durability as the teeth. Even you can bite a bone with the zirconia teeth. So glass ceramic, we all know what the glass ceramic. Glass ceramic have shiny polishing surfaces. For example, if you take a toilet, or you could take a cup and saucer, this has this ceramics. So basically it has this thing. Okay, so these are examples of ceramics. See, all you could see all those pictures. See, this could be a glass, glass ceramic, when which it's a shiny, and these are the best examples. You could see it. See, this is a portrait which has been made from a ceramic, and this is also a astronaut suit which is made with the ceramic, and this is a pot. It's a flower pot, which you can. It's also made with a amorphous material. See, the amorphous material is nothing but the material have no regular arrangement of their molecules. So, in the other word, I would say like in condensed matter physics and material science, an amorphous or a non-crystalline solid is a solid that lacks the long-range order, that is characteristics of a crystal. In some, they have been like used as a glass. It could be used as a glass. So amorphous materials are those that have no detectable crystalline structure. Okay, so basically these material have no regular arrangement of the molecules, and material like glass and paraffin are the examples of amorphous material. So these are the best examples because they don't have a detectable crystalline structure, crystal structure, I would say. So these materials have the properties of solid, but they have definite volume and shape and diffuse slowly. Diffuse slowly means the for example, if you place a glass, when a light ray penetrates, the diffusing time will be very slow. It will take more time. So different glass materials are there. So that's different materials. Okay. So unlike a crystalline solid, an amorphous solid is a solid that lacks an ordered internal structure. Some examples of amorphous solid include rubber, plastics, and gels. Glass is a very important amorphous solid that is made by cooling a mixture of material in such a way that it does not crystalline. So it will not go to crystalline. So this is a crystalline, polycrystalline and amorphous. So crystalline where in which all the molecules of all the atoms are arranged evenly. In polycrystalline there are some gaps are there. And when you take amorphous, see there are so many gaps inside between this. So crystalline is totally different from amorphous. So amorphous carbon, this is amorphous carbon. So how the gaps are there? So when there is no gap, that's called a crystalline, and there is some gaps, there are some continuous arrangement and some gap is there, means that is called the polycrystalline. And when there is no gap at all, means so there are so many gaps inside it, that is called the amorphous. So a crystalline is a small, sorry, a polycrystalline. What's a polycrystalline? Polycrystalline material or a polycrystal or solids that are composed of many crystallites of varying size and orientation. Most inorganic solids are polycrystalline, including all common metals. Many like ceramic, rocks, and ice are the polycrystalline materials. Okay. Crystalline is nothing but having the structure and form of a crystal composed of crystals. So this is the crystalline. So in crystalline, the crystal structure is a unique arrangement wherein which the arrangement of atom in a crystal structure is composed of a unit cell, a set of atoms arranged in a particular way which is periodically repeated in the three-dimensional lattice. See, that's the reason if you say crystalline, the atoms arranged in the particular way, it is repeated again. So in the first 1, 2, 3, 4, 5, 6. Second, there is more than 6, and then other next one is again 6. So it is like a uniform. So where the arrangement of the atoms are in a proper precision. But in polycrystalline, the arrangement of atom is not there, and amorphous, it's completely totally different. The crystalline materials. In crystalline structure, the atoms are arranged in three-dimensional arrays called a lattice. So the lattice has a regular repeating configuration in all directions. This is an example of a lattice. So see when you take this crystalline structure, there is a three-dimensional array of a lattice where in which all the things are arranged in a proper manner. So these pink lines, if you take the atoms, the black line is another atom where in which this everything are arranged in a particular direction. So this is seen. The lattice has a regular repeating configuration in all directions. So everything will be even in all the directions. Polymorphism. A crystal is defined as an orderly array of atoms in space. So normally metals are made up of number of crystals, and each crystal consists of large number of atoms. So basically polymorphism is nothing but, simple word, what is polymorphism is nothing but the condition of occurring in several different forms. Okay, so that is occurring different forms, several different forms, that is the polymorphism. So in other words, polymorphism is the property of something having many forms. So having a many forms, a thing that has many forms is a polymorphic. Appropriately and perhaps confusingly, its meaning takes many forms, notably in computer science and biology, in object-oriented languages, there are more than one kind of polymorphism. So normally metals are made up of number of crystals, and each crystal consists of a large number of atoms. The crystal structure is atomic arrangement in solids. Polymorphism is the ability of the solid material to exist in more than one form or a crystal structure. So this is a crystalline and polycrystalline amorphous, as we already seen it in the previous video. So this is a unit cell. So this is a single atom, this is a unit cell, and this is a lattice. So let me tell you what is lattice. A structure consisting of strips of woods or metal crossed and fastened together with square or diamond shaped space left between under as a screen or fence or as a support for climbing plants. So that is like this. If you take it, it looks like like a fence or like a window material that is like which is like material has been fastened together, right? So this is the lattice. So basically you could see this like a grid. It looks like a grid, right? So with this we come to the end of the video. So we have discussed about the various types of engineering materials, and we also studied about the properties of the materials. So these are the reference books. You can go through this books for more for reference. So thank you guys. Thank you for seeing this video. So we will continue the next video. We will continue the next part from the next video. So, thank you guys.